All right. Welcome, everyone. The Platform Sprint 79th review. My name is Balázs Bézi. I'm Scrum Master of some of the teams here, of the platform teams. And we are planning this review to finish it around 60 minutes or under 60 minutes. That's the goal. And of course, it depends on your questions, which you can raise in the comments. We try to answer those questions as well as in written format in the comment section, as well as the very end, the last session of this review is going to be the Q&A, where we answer your questions as well. So please feel free to raise your questions. Please give us feedback and comments. We are waiting for that. We are doing this for your feedback to gathering insights from you. And please make sure that you are also putting the context of that question that you are raising, because when we are getting back to that question half an hour later, maybe we might lose context and we cannot make sure that we can answer properly to your questions if you are just asking without the context. And without further ado, I hand it over to Maciek. Thank you very much.
Thanks, Balázs. Hi guys, my name is Maciek, and I would like to bring you a brief introduction to what will be presented here today. So the ultimate sprint goal for all of the platform teams were fees calculated for all possible platform operations. And this has been accomplished, but you need to know that it's not like the fee mechanism isn't yet integrated in the platform, but it's like an independent module that is working, that's operational. And here, Sam will be making a robust presentation how it works, how the fees are being calculated. You can also count on some. Beside that, you can also count on some performance comparison of our storage, how fast it is, and how comparing the storage operations and also the transactions in the platform. So yeah, this will come with this nice, let's say, user-facing demo. But beside that, we'll also go through Tender Dash consensus, GrowthDB, and obviously the client SDK. By this moment, I should also inform you that well, Tender Dash will Łukasz in particular will bring you some update on some consensus error that we faced, and it affect the testnet, which was down for more than a day, but fortunately it has been resolved. So you feel free to use the platform from the developers. I mean, developers are free to use the platform and continue their project. And the root cause is still being under investigation, and like the fixing process. Let's say that fixing process is in progress. Yeah, I guess that there are the most important stuff. Obviously, you will also hear some nice updates for the client SDK, and at the end of the meeting, I will elaborate a bit on the further plans for upcoming weeks for teams related to all of the components that are included in the platform. So thanks, Balázs. I'm done right now, and let's hand voice to Łukasz.
Hello, my name is Łukasz, and I'm one of the Tender Dash developers, and we work hard to get the consensus engine up and running and implementing all our advanced features that are needed by other elements of platform. The role of Tender Dash is to ensure that each node on the network can see the same state, so that the drive can communicate with Tender Dash save some information in some state of the drive on its local node, and this information is propagated to all the other nodes in a reliable way. Our three main tasks that we were working on this last period were first stabilization of version 08, which is basically a backport of Tendermint 0.35 to TenderDash, so that we are taking everything that Tendermint team did in that version 0.35 and integrate it back to the TenderDash. And we did all the tasks that we had in terms of stabilization of this version and this backport, and we created a pre-release version. Right now we are on the deployment and integration step, so we need to do some work together with the platform team to integrate and update Drive and TenderDash integration. We also started backport of most recent, let's say, minor releases of Tendermint, which are 0.35.1 and 2. 2 is almost done. We need to QA it, and 0.35.1 is done. So we are going quite well, in my opinion, with that. And on the next slide, we can see that we also did some not planned work that arise during the backports and during the tests that we did. First thing was to improve our GitHub CI workflows to make it easier to backport changes, which were quite significant in Tendermint. We also improved tests and test infrastructure that is built into TenderDash for automated testing. And we did one change in the config file format. We removed isMasternode setting with mode equal to validator. That's also due to the changes upstream in Tendermint. So we are unifying that and removing our configuration option that was right now superseded by upstream config option. And the last thing that we worked on was the test net outage. We got hit by some edge case that caused the network to stop, because the blocks were that are generated before the block was accepted. New block was accepted. Some timeout happened, and the network got stuck due to some combination of multiple items. And this status of this is that we have a good understanding of what happened, so the bug fix is in progress, and we also implemented already the workaround. So right now the network is up, and the test net should work correctly, and we will be releasing in the next few days a bug fix release to fix that issue permanently. And that's it on my side.
Thank you very much, Lukasz. And Wisdom.
Hey guys, my name is Wisdom. I'm one of the developers on the GroveDB team. So we continued with proof implementation for the second version. Last sprint, we worked on modifying ARC, which is the subtrees, to undo the limit offset functionalities. And now we are using that work to combine multiple subtrees in order to generate proofs for the entire GroveDB tree, which is a combination of many of these subtrees. So one of the things we did was we propagated the limit and offset values from each subtree for both construction and verification. So this way we can use the results from one subtree as inputs into another subtree, thereby creating a chain-ish situation between the trees so that we can verify that everything was constructed correctly. Then we also worked on generating proofs for path queries for GroveDB. So a path query is basically a definition and then a query definition that goes through the GroveDB, basically instructions for how GroveDB should select a subtree or select a series of subtrees. And so we needed to generate proofs for this, which not only proves the subtree, but proves that the subtree and the collection of subtrees up to the roots generates the exact same root hash. So we implemented construction of proofs for this and also verification of proofs for this. Now we are working on implementing subqueries, proof construction with subqueries. So this way, when you select a subtree, if the elements of the subtree are also trees, then you might run a conditional query on those elements. And so you need to also be able to prove that this subquery's proofs were constructed correctly. So that is what that is currently in progress. Yeah, we should have a demo showing the entire proof system on the next review. So that's all from my end.
Thank you very much. Igor.
Hello, everyone. My name is Igor. I'm a software engineer at SDK team. And now I will quickly introduce you in what we did this sprint. This sprint was about testing. We were running platform test suite many times against the testnet. We were identifying all the bottlenecks and problem places and so on and so forth. And I'm happy to say that we managed to get more information on steps to reproduce, how to reproduce some randomly occurring bugs, which are rare, but they are quite annoying. And we fixed a couple of issues with SDK related to transactions queue broadcasting, and we optimized wallet end-to-end test, which in Dashmate, for example, was running quite fast, but in real network, it took some additional 10 minutes, which we kind of saved with this optimization. And some fixes for chain timeouts. Basically, it's also revealed on a bigger scale, where there is a bigger network, it needs more time to reach a consensus, right? So we needed to kind of optimize this setting for testnet. The third bullet point is about the Dash Incubator request. They asked us to provide additional fields for ease of usage for transaction history. Such field includes transaction balance impact. It might be negative or positive number, depending how it impacts the balance, whether this is receive or send, and types of addresses for inputs, whether this is external or internal wallet address or unknown address or other account of this wallet. And we also added fee impact to this information. Fourth thing is about SPV. In previous sprint, we faced some issues with verification of headers with our Dash SPV library, and we were debugging that and researching the exact reasons for such behavior. And yes, last but not least, two last bullet points about the storage improvements, and SPV block headers are in progress. They are kind of tied to each other, and also they were tied to some of the bugs we fixed. So progressing in this area as well. That's all. Thank you.
Thank you, Igor. And protocol. Sam.
Yes. Sure. So protocol was focused heavily on a few different things this sprint. There was work on fees. there was work on, well, I'll let other people in the team talk about the rest of the work on the next slide. But in this slide, I'm going to talk about fees. As we said in the previous weeks, our fee model is kind of dependent on two things: a worst case scenario and a runtime fee calculation. So if you think of it in a way, you create your data contract, and in your data contract, there's pretty much a worst case scenario for anything that you might submit to platform. And you have to have the worst case scenario worth of fees in your account before it is passed, before it is the transaction is basically relayed. So that's kind of the worst case fee calculation. And then as transactions are used, there's something called the runtime fee calculation that basically figures out exactly how much fees you are using and removes that from your account. And I'm going to be making a demo later. And in the demo, I think this will all become super apparent and explain and very understandable. People will be able to understand a lot more how this works. The fee calculation module that was created basically takes a list of operations that can occur, a list of writes and a list of reads, a list of like things that are put into memory, a list of disk writes, and based off of the exact size will output a value on the fee that the document will or the operation in fact will take. To write this code in a very specific, to write this code, what was done was that instead of creating two code paths for the worst case scenario and the runtime scenario, instead one code path was created that created an enumeration between runtime and worst case. So it actually follows the same code path for worst case in the code, just passes an enumeration that every single time it figures out like how much it's inserting, it just takes the worst. And this basically makes it so that anytime a code change happens in the code, like if you modify any part of this critical code, you don't have to modify it two times. So this architecture that was built for fees was much harder than the more naive approach, but it is very it's a lot more solid to do it this way. And I did want to talk about that because well, a little bit proud of it. Okay, so so I talked about what the fee calculation module is. There's also a binding for JavaScript that wasn't yet completed for that module. Calculate the fees at runtime, calculate the fees at applied document, update the node bindings now for applied contract and applied document, basically giving back now not just one fee, but the storage part of the fee and the processing part of the fee. I talked about this, or somebody had talked about this, I think Paul actually, a few weeks ago, that there are two components to fees. There's the storage part that gets actually distributed over a long time, and then there's the processing part that gets distributed pretty much immediately, or in a more recent time frame, like in the next week or so. And the storage actually gets distributed over 50 years following an inverse logarithmic function. So wait, is it inverse logarithmic or inverse exponential? Sorry, forgetting some things. Okay, so next slide, please. Yeah, so with that, I'll pass it on to Kostya, correct?
Yes.
Yeah, right. Thank you, Sam. Hi, everyone. Let me tell you a few words about our progress. So the first thing, we added additional purpose withdraw for identity public keys. And this type of key can be used only for withdrawal purposes. I think it's pretty clear. And the second one, we have implemented the identity update transition, which allow users to update their public keys. This can be useful, for example, if your public keys were compromised or some similar reasons. So we can either add new public keys or disable existing ones. Keys can only be disabled if another valid key is enabled in the same security level. And this can happen automatically in the same state transition. So we can add one key and disable the old one at the same time. And not planned tasks. So the first two things, these are bugs in Dashmate. The first error was during Dashmate setup in some cases, and the second one was related with Dashmate's config migrations. So when we update Dashmate from the old version to the new one, we can get this error. And the last bug is a bug in our testnet. It is related to TenderDash. So in 2 words, the reason was that in some cases, proposal block time was not in proposed block time window. Yeah, and right now we're testing our solution to fix that. So that's it. Thank you. I guess.
Thank you.
Javid.
Javid.
Sure. Hello, everyone. Javid's here. Quick update on our future work for integrating TenderDash v0.8 dev. So we already started this work. For now, we're kind of in a playing with it state. So we're trying to integrate TenderDash and Drive right now. A few issues already has been fixed, like Dashmate side of things with configuration files for TenderDash, as well as message parsing, since it's been bedated. However, we're still figuring out issues with running those two together on local DevNets. And that's basically it, I guess. So I should pass my torch to Sam.
Yes. Yes, I'm not muted. Excellent. Yeah, so there is one other thing. I think the second thing we'd already talked about, the runtime fee calculation. Instead, what should actually be written here is the deterministic worst case scenario fees. And that's actually done. And the update node.js binding was all of this stuff was done. Second line, ignore that community. It was all done. So another thing that I worked on was contract reference support in RS Drive. This actually did exist in previous versions, and we had disabled it because RS Drive did not support it. The new system using GroveDB just did not have that. It wasn't actually that hard to support it. So I just coded it in one day and we got it in. It wasn't planned. It was actually that there was a test that we had that used references, and I either had to make a new test or code in the the actual functionality. And I was like, I don't feel like redoing this test. Let's see how hard it is to code into functionality. So now we have reference support, as we did in previous in versions before v22. Okay, so I'm going to do a fee calculation demo to kind of show people how things are currently working. And yes, let me share my screen. So this is a terminal demo. It doesn't look extremely nice, but actually, let us go exit, start from scratch. So before, a few weeks ago, I had shown a demo on a project called RS Drive example, I think. And now it's called RS Drive Explorer because I added a lot of functionality to this little terminal program. So to start it up, just have to run it in Rust, and we're going to run it as release. Sadly, there's still some warnings that I haven't dealt with. There are three initial options to do. The first one is to load the person contract, and that's just like a demo contract that is created. And then you can play around with the person contract. It has first name, middle name, last name in the contract, and an age. And I kind of think that that's what I gave as an example before. But now another cool feature is that you can load any contract. So people in Incubator that are making a contract can load it right now and figure out like the worst case scenario fees for the contract, and a lot of other somewhat goodies in terms of insertion time. So I'm going to instead of loading one, I'm just going to do load last. And this actually is preloaded with the DashPay contract because the last one I loaded was DashPay contract. So press load last. And if we see here, we can actually view the contract structure. So here we have the DashPay contract that has a, I hope people can actually see my screen properly, but it has a created ad and updated ad. I think some people are familiar with the DashPay contract and what it looks like in terms of stuff that it has inside of it. You have the DashPay profile, when you created it, when it was last updated, the avatar that you're using, your display name, a public message, and then the I's here mean the current indexes that exist on various, you know, on your profile, on your contact request, on your contact info. So as you can see, there's some indexes here, and if the index is unique or not. One cool thing that I built in here is that it's not very easy to test when you want to create random data, right? So let's imagine that you want to see how long it's going to take you to create 100 profiles in storage and how fast that is. So here we're going to do, well, let's start with just one, profile one. So right here, what I'm doing is I'm populating the data storage, and I'm inserting it into the storage, one profile that is randomly generated. So here we go, pop profile one. And you can see that the storage fee for this profile was 1 cent and 46. This is not $1.46. It is you know, $0.01 if in terms of credits. If we look at, this is actually probably not a normal profile because the actual avatar path can be extremely big. And if you look at the time taken, yes, it took 0.004 seconds, and these are somewhat of the fees. If instead we were to insert a profile, so if we look here, what it looks like is a profile has a created ad, which is a date, an updated ad, which is a date, an avatar, URL, a display name, and public message. We can do profile one because a date actually is a timestamp, and one would be 1970. pretty much. We can do one here too. Avatar URL. Well, I can take a cat picture online. Let me find a cat picture. Cat picture URL. 1 second, guys. Place kitten. Yes, yes, yes. Perfect. Like that. What else do we have? Display name. Kitty. And public message. Catnip. Something like this. Okay, so if I were to insert this profile, there we go. This is like what you would normally see as a trend, as the profile fee. It would be 0.32 cents, which is, in my opinion, pretty good for a real real use case. Processing fee is pretty much 0 cents, and the time taken is very fast, as we can see. Now we can also do a random profile population of, let's say we want to insert 1,000, well, maybe not well, we could do 1,000, whatever. Let's add 1,000 profiles. See how quickly that takes. It took 1.4 seconds to insert 1,000 profiles. It costs $10 for those 1,000 profiles. And then we can actually look at our data. So let's do here, and let's look at all our profiles that we created. All profile. So let's see what we have here. Okay. So there were 1,002 profiles. With an ID and owner, the time that they were created, updated, the avatar URL, the display name, and the public message. Somewhere along here, we're going to find Kitty. Where's our Kitty? I shouldn't have put in 1,000. Now I realize. Oh, God. Oh, God. Well, actually, let me just search for Kitty. No. Oh, there we go. We found it. Okay, here it is. The one that we inserted, Kitty. Oh, there's a display bug here. Okay, nobody saw that. And so yeah, you can basically insert a specific item. We can also delete if you want to delete something. So delete from the profile this item. Yes, that should work. Deletion actually gives you back credits. I forgot to tell how many credits you would have gotten back on your account or your identity. And in here, we also have the worst case scenario. So now you've seen the set, it was like 0.34 cents to register a profile. Now, what would be the worst case scenario for a profile? And we're going to get into some interesting rare case scenarios here. So the cost of the profile is actually 17 cents in the worst case scenario. And there's a lot of storage going on. And if we look at why that is, we go into here and we see that the avatar URL has no minimal, but the maximum is actually 2,048 characters. The display name is 25 and the public message is 124. What we have to think about is that the max here is that are not bytes. They are actually Unicode characters that have up to 4 bytes. So if you were to register such a contract with a max of 2048, you can actually insert up to 2048 times 4 bytes. 8,192 or something. I don't know. So yeah, and we can actually show that really quickly with a pop full. So pop full is basically going to make a full item that that isn't a random avatar URL. It's a random string, but of 2048 characters, but they're ASCII characters. So they're 1 byte each and not 4 bytes. So popful profile 1. And you can see here that it's 1 cent, 1.72 cents. And yes, and that's because we're not dealing with crazy worst case scenarios around bytes. Actually, there probably is another error here, because even if that was the worst case, we would only see 4 times 1.72 cents, and that's not 10 times. So I have to look into if there's another worst case thing, maybe with a date or index or something interesting there. Okay, so let me see. Are there any other functionalities that I haven't covered?
Sam, just a question here that came, that they were asking, where are these images stored?
Where are images stored?
Yeah.
Oh, like avatar URLs?
I'm not sure.
Oh yeah, yeah.
Actually, where is the actual data?
Yeah.
Where is it stored in the platform?
Oh, well, I'm going to answer both questions because I think both will be interesting. So in terms of in DashPay, we're not actually storing avatars on the chain, because storing pictures on the chain opens up to multiple problems. First, they're very big, they're very costly, and second, you get into moderation issues, especially when your apps can look at these pictures. So yeah, we're not actually storing them on chain. We're storing instead the avatar URL, and we're using a decentralized caching system that Incubator has been working on, and hats off to Incubator for that. To cache images in a decentralized way. So if the original server goes offline, the avatar URL will actually be able to stick around for a little bit of time, and other benefits of decentralizing the system. So that's for pictures. For where the storage is happening, yes. So right now it's happening on my local machine right here, because this is just access to the Drive database. However, when we go to mainnet, not when we go to mainnet, but when we have this on testnet or anywhere, it's actually like on the master node. The interesting part of all this is the way the fees work is that the fees don't get given out immediately to masternode owners, like in a lot of other chains. That would just be a simple solution. And obviously we don't like simple solutions. We came up with a much better solution, which is they get put in buckets that get distributed over time. So like that, if somebody comes in and creates a masternode in 10 years from now, they're not having let's say the state is 5 terabytes. Well, in other systems, often the 5 terabytes, you just have to, pay for that storage, right? And try to recuperate fees because of current hosting. But instead in our system, you'll get the money of whatever that leasing of storage per month actually costs coming back to you at all times. So the only bad case is if the Dash price were to drop heavily, yes, you might not recuperate, you might get under the threshold, but the storage part of the fee is distributed over time in such a way that it's always profitable, or it should be always profitable to run a masternode. I hope that answered the question. Let me check to see if in the stream if there's anything. Okay. Okay, cool. Yeah, so let us continue. I'm going to stop sharing. Wait.
Are you done with the demo?
Yeah, did I already stop sharing?
No.
There we go. Yes, I'm done with the demo.
Okay. 1 sec. Here you go.
Oh, yes. So this is also an interesting slide. Paul, who gave the feed presentation 2 weeks ago, he was working on document insertion time testing, basically figuring out how fast the time of insertion currently is. And he came up with the following values. So if we were to insert a document with 100 strings, most documents, by the way, do not have 100 strings. They would probably have like, I don't know, 5 or 6 strings in a normal contract. Oh, yes. And, but currently in Drive, such an operation takes for storage, what is that? 0.8 milliseconds. So extremely fast, actually. However, it's currently taking 0.24 seconds to insert the document. And this is actually not good. It's because of there are 3 main components right now to how our system works. There's the validation aspect. There's a bridge between our validation that happens in JavaScript and and the storage that happens in Rust. And then there's the Rust based storage. JavaScript is slower than Rust. I think that that's a common thing, and I'm not going, most people that know languages know that fact. But it seems like the biggest issue that we're currently facing is the bridge between JavaScript and Rust. The state transition times here for including these state transitions are at current time a little bit too slow to go to mainnet, because we want, I mean, these are very complex state transitions, like 100 indexed regex strings or 100 indexed strings. Those are not standard. These are much more bigger than a normal state transition. So, but we still need better performance than this. So we're going to be working in the next few versions to increase performance of the state transition times overall. Most likely, this can be easily achieved by having a little bit of caching on the bridge side. And yes, so that hopefully will alleviate a lot of this. When we look at the fact that the storage percentage of the total time is only 10%, then in a normal system, that should be more like maybe 80 or 90%. We realize that the actual storage times that we should be expecting for the system are much closer to the second column. By the way, these values are taken on it's not on a very fast computer. Sorry, Paul, giving some personal information away. But so, I mean, on my computer, it's already 10 times faster than these values. And on the Mastodon network, it would also be faster than these values. So it's to be taken with a grain of salt. What we need to pretty much represent here is more the fact that the storage is at 9 or 10% or 0.33%, which is extremely low, of the total time, which means that there's a lot of optimization still to be had, and also means that our storage is extremely efficient. Okay. So with that, Maciek?
Yeah, sure. So yeah, thanks Sam for this awesome presentation. It was really nice to see the comparison of the timing of executions and the fees itself. Like as Sam explained, this will come with additional tweaks before being ready with the final version that will be in the whole platform service. But yeah, you can at least have some early perspective on that. So hey, as we're getting to the end of the meeting, I would like to say a few words about the plans for our teams for upcoming weeks. So the protocol team will be still working on fees. We can call it as the next phase of this whole platform fees project, and we'll be slowly getting there to being able to just integrate this implementation with the whole service, so it will just be consistent and integrated. Complete identities according to DIP 11, so this is still ongoing, and yeah, thanks to our community, especially the Incubator. They are really focused and they're helping us with investigating the early issues with the version 22. So we have some list of issues that should be addressed, and we'll be just planning them along the timeline with keeping in mind the most critical ones and the most, let's say, painful ones, as they should go first. Yeah, regarding the client SDK, still the integration of SPV block headers. This is a more let's say ongoing project, and we still need some time to work on that, but that's the current goal. Yeah, on the storage side, and in particular on the GrowthDB side, the same objectives. This is a similar case as SDK. Those projects are more let's say long-term in the perspective of days, and we still need some time to be working on that, but this is the direction. And for our consensus engine, yeah, we need to finalize the backport. I mean, we need to finalize backporting the version 0.35, which will allow us to get the upstream branch, which includes the ABCA++ project that is supposed to resolve our issue with with signing the state of the two previous blocks instead of the current one. So this will come with some of our research and investigation, but we are already there to start this process. And yeah, the thing that I mentioned at the beginning, we faced some issues with the platform testnet, and the source of that were on the consensus side. So this stabilization means progressing with the fix for the version 0.8 that the platform currently runs on. And yeah, that would be it. I think that I mentioned all important stuff, guys. If I missed something, then please also make a comment. But I guess that we can just move to the questions part. Some of them have been already answered, but okay, Balázs, feel free to continue on that.
Yeah, let's see. Thank you very much. Thank you guys for all these, sharing these, and we are still waiting for your questions. But let's get down to it. So I'm coming from the latest to the earliest. How scalable will platform be?
Well, I can answer all these things. It's a little bit of a interesting question. How scalable will it be? Because it's quite subjective. There's no yes, crazy scalable or very little scalable. We have an internal goal of 500 transitions per second that we will try to get an average transition, because the real issue is that it really, really depends on how big a state transition actually is to know like how many we can handle. If we wanted to handle the most minimal state transitions of the system, we could probably handle, a few thousand. But if we wanted to handle the average one, it's probably going to be about at the moment, I'm not 100% sure. This is the work that will happen when we're ready. Currently, we don't handle that many, but the work that's going to happen in V23, in V24 should push us to something that can have quite a lot of initial capacity, much more than we'll most likely need in the first few months. How we scale later is an interesting topic. We have masternode quorums, and one idea that has been brought up is using various quorums to distribute load to have a much more, to basically have almost an infinite scalable capacity, because that's really what scaling is. It's the ability to add more infrastructure when you need it. We don't have that in the first version. We have something that will have a good throughput, but it won't be able to scale by adding more infrastructure. But again, the consensus inside the team is that it's good enough for now. And we probably will not reach those capacity limits. And if we do reach those capacity limits, that's pretty good. That's a pretty big win for our system. Okay. So I hope that answered your question.
Thank you. So the next question is, what kind of integration / functionality with the base payments layer will MVP include? For example, making a payment for an amount specified in a data contract.
Yeah, so in the first version, we include Dash Pay that is shipping with version 1 of platform. So I'm not completely I don't completely understand the question. I hope that's what was meant. And if not, Lord F, maybe you reply and we'll get back to it later.
Yeah. All right. I see Brian already answered the Dash Pay related question. And the NFT capabilities. If it is not answered, please raise it again. NFT capabilities. That's a question that I think we need to do a frequently FAQ, frequently
ask questions.
Ask question. Thank you. So, what NFT capabilities will come out of the box for platform? What attributes can you assign to one? Would it be possible to transfer them to others?
Okay, so NFT capabilities, well, very high in terms of you can associate a lot of data to any NFT. You can create a data contract that allows for NFTs. Platform is extremely good for that because pretty much all documents are NFTs, and that's what we're basically storing. The negative side of this is that in the original vision for what we were going to release as an MVP to get out as quick as possible, we were very focused on Dash Pay. And because of that, Dash Pay, contact requests make no sense to be transferable. It's a really low-hanging fruit to make them transferable. So we're going to try our best to include that functionality before mainland launch, just because it is not very complicated to do so.
All right. Thank you very much. I don't see any other questions. So I would like to thank everyone questioning, raising your questions and giving us feedback. As much as said at the very beginning in the chat, if you have any feedback regarding this way of communicating to you, please leave a comment for that as well. And I think we can wrap it up. Yeah.
Well, there was actually the Lord F that did a reply to what extent we can create programmable payment dApps.
Okay.
I would say probably not in the first version. You won't have that ability without smart contracts. So you won't be able to do things like recurring payments because we just don't have that functionality in the first version.
All right. Do we have any other comments?
But when we do have smart contracts, we probably will. You will be able to do that.
All right. All right, then. Thank you very much. And see you later in 2 weeks, I guess. Thank you.